Imagine if software developers had to start from scratch for every project. Sounds exhausting, right? Thankfully, they don't have to. Welcome to our discussion on reusability in OOAD. Reusability is a fundamental principle in object-oriented analysis and design, commonly referred to as OOAD. It's all about maximizing efficiency and reducing redundancy in software development. But how do we achieve this? By emphasizing the use of existing components, code, or modules in new contexts or applications. It's like having a toolbox of ready-made solutions that can be applied to various scenarios, saving you the hassle of creating new tools each time. This concept prevents the need to reinvent the wheel. Imagine having to craft a new wheel for every vehicle you build. Sounds time-consuming, doesn't it? Well, that's exactly what reusability in OOAD helps to avoid. It involves creating software components, classes, or code structures that can be used in different projects, applications, or scenarios without significant modification. This allows developers to focus on the unique or differentiating aspects of a system, rather than spending time recreating common functionalities. Picture this: you're building a house. You wouldn't chop down a tree for every single wooden plank you need, right? Instead, you'd create a template for the planks and replicate it. This is the essence of reusability in OOAD. It's about creating templates, or in our case, software components, that can be replicated and reused across different projects. Reusability is more than just a time-saving mechanism. It's a strategy that enhances efficiency, promotes consistency, and ultimately improves software quality. It's a key player in accelerating development, making it an essential concept in the realm of OOAD. So next time you're working on a project, remember to look into your virtual toolbox first. There might be a solution already waiting for you. After all, why waste time crafting a new tool when you can effectively use an existing one? Understanding reusability in OOAD means appreciating the art of efficiently using what's already available. Now let's delve into why this is beneficial. Why should developers care about reusability? The answer is simple. It brings numerous benefits to the table. Firstly, reusability promotes efficiency and productivity. By reusing existing components or modules, the time and effort needed to create new applications are significantly reduced. This means less time spent on coding and debugging, and more time spent on innovative and value-adding tasks. Secondly, reusability ensures consistency and standardization. By reusing code or components, developers can ensure consistent behavior across different applications. This not only simplifies the code base, but also promotes standardization, making it easier to manage and maintain the software in the long run. The third benefit of reusability is reduced maintenance costs. When developers reuse tested and proven components, it leads to fewer defects, which in turn reduces the need for bug fixing and maintenance. This can result in substantial cost savings over the lifetime of a software product. Reusability also encourages modularity. In a modular design, each module or component has a specific responsibility, making it easier to maintain and update the system. This also makes the software more flexible and adaptable to changes, which is crucial in today's fast-paced tech world. Lastly, reusability accelerates development. By building on existing work, developers can deliver new features or products much faster. This can give companies a competitive edge, as they can respond quickly to market changes and customer demands. In essence, reusability is about leveraging existing resources to maximize efficiency, improve quality, and accelerate development. It's about working smarter, not harder. As you can see, reusability is not just about saving time, it's about enhancing the overall quality of your software. Now, how do we achieve this? Achieving reusability may seem challenging, but with the right strategies, it can become second nature. The first strategy to achieve reusability is to design with reusability in mind. This might sound obvious, but it's often overlooked. When developing classes and components, we need to ensure that they are generic enough to be reused in multiple contexts. However, they should also be specific enough to fulfill their responsibilities effectively. It's a delicate balancing act. Avoid hard-coding specific logic or dependencies into your components, as this can limit their reusability. Instead, aim for a clean, flexible design that can adapt to different scenarios. Now, on to the second strategy, utilizing object-oriented principles. These principles, encapsulation, inheritance, and polymorphism, are the backbone of reusability in object-oriented design. Let's start with encapsulation. Encapsulation is about bundling data and behavior within classes and exposing only what is necessary through interfaces. This not only hides the internal workings of a class, but it also makes the class easier to reuse, as it can be treated as a black box that performs a specific task. Next, we have inheritance. Inheritance allows us to create a base class with shared behavior and then derive classes for specific implementations. This can be a powerful tool for reusability, allowing us to reuse and extend existing classes without having to rewrite them. Finally, we have polymorphism. Polymorphism allows different classes to share a common interface. This means that we can use objects of different classes interchangeably, as long as they implement the same interface. This flexibility can greatly enhance reusability, as it allows us to design components that can work with a variety of different objects. These strategies are just the beginning. Next, we will explore how design patterns can enhance reusability. Design patterns are like the secret sauce of reusability. They provide solutions to common problems, making your code more reusable and easier to understand. Design patterns are best practices that experienced developers have learned over time and packaged into a reusable format. They provide templates that can be used to solve common programming challenges. Let's delve into a few key design patterns that enhance reusability. First off, we have the factory pattern. This pattern is all about creating objects without specifying their exact classes. It encapsulates the object creation process and gives you flexibility, making your code easier to manage and more reusable. Next up is the strategy pattern. This pattern is about defining a family of algorithms, encapsulating each one, and making them interchangeable. This approach allows you to change the behavior of your program at runtime without changing its structure, enhancing reusability. The singleton pattern is another valuable tool. This pattern ensures that a class has only one instance and provides a global point of access to it. It's particularly useful when you need to coordinate actions across a system, reducing redundancy and promoting reusability. Then we have the adapter pattern. This pattern converts the interface of a class into another interface that clients expect. It allows classes to work together that couldn't otherwise due to incompatible interfaces, enabling you to reuse classes in different contexts. Finally, there's the decorator pattern. This pattern lets you add new behavior to objects dynamically by placing these objects inside special wrapper objects. Using the decorator pattern, you can add or remove responsibilities from an object at runtime, promoting reusable and flexible code. These design patterns are just a few examples of the many tools at your disposal. They are tried and tested solutions that can make your code more robust, maintainable, and most importantly, reusable. These patterns are your tools for creating reusable components. But there's one more strategy to cover. Our final strategy for achieving reusability is component-based development. This approach is all about building reusable blocks of functionality. Component-based development is a tried-and-true strategy for achieving reusability. It's about designing reusable components that are like Lego blocks. Each component has a specific role and provides a particular piece of functionality. These components, with their well-defined interfaces and clear boundaries, can be used, reused, and arranged in various ways to build different applications. Think of a component as a black box. You don't need to know how it's implemented inside. You just need to know what it does, its functionality, and how to interact with it, its interface. This encapsulation of functionality and interaction makes a component reusable across different contexts. Now, how do you go about creating these reusable components? It starts with a thoughtful design, considering how the component might be used in various contexts. The key is to make the component generic enough to be useful in different scenarios, yet specific enough to provide meaningful functionality. But it's not just about designing and building these components. It's also about managing them, ensuring they're properly tested, versioned, and documented, so they're ready to be used and reused. And what about facilitating component-based development? Well, there are many frameworks out there that support this approach. Angular, React, and Spring, to name a few, all provide robust support for component-based development. They offer features like component libraries, easy-to-use APIs, and a supportive community, making it easier to build and manage reusable components. So there you have it. Component-based development is a powerful strategy for achieving reusability. It's like having a toolbox full of tools that you can pick and choose from to build your application. It's about being efficient, being productive, and building on the work that's already been done. And that wraps up our discussion on reusability in OOAD. Remember, efficient software development is all about reusing and building on what already exists.